In this video, we will try to solve a question that was asked by a brother. The question is like this. If commodity X1 is the function of P1 and P2, where P1 and P2 are the price of commodity X1 and X2. Similarly, X2 is given as the function of P1 and P2, where P1 and P2 are the prices of a commodity X1 and X2. Then the two commodities are substitutes if the first option is given as the partial derivative, that is dx1 divided by dp2 is less than 0, and dx2 divided by dp1 is greater than 0. Second option is like this: dx1 divided by dp2 is greater than 0, and the partial derivative, that is dx2 divided by dp1 is less than 0, and so on. We are given these four options. Okay, we have to see what is the condition for the two commodities to be substitutes. Okay, first of all, we know that the two commodities are the substitutes of each other if increase in the price of good X, in this case, increase in the price of good X1 increases the quantity demanded of good X2. Then the two commodities are the substitutes of each other. Okay, that means two commodities are substitutes. I will write here that increase in price of, let us say we are given here x1 uh, increases the quantity demanded of x2. Okay, so that means if the price of that is if price of x1 increases, and if it leads to quantity demanded of x2 to increase, then the two commodities are said to be the substitutes of each other. So first I will give the basic intro about this, then we will solve this question. Okay, let's take a simple case, that is tea and coffee. Okay, we say that tea and coffee are substitutes of each other. That is, if the price of coffee increases, quantity demanded, that is, if price of coffee increases, quantity demanded of the tea will also increases. That means if tea is the substitute of coffee, then invariably it means that coffee should also be the substitute of the tea, and it makes the sense to look at it both ways. That is, if tea is the substitute of coffee, then coffee should also be the substitute of the tea, and it makes the sense to think like this. Okay, now coming to the question. The question is, we are given the demand functions, that is x1 is the function of p1 and p2, and x2 is also the function of p1 and p2, that is the price of good x1 and price of good x2. Okay, so the condition for the two commodities to be the substitutes, I will show it here, but first I will give try to make it clear by an example. Let us say we are given the tea and coffee. Okay, we are given tea and denoted by x1, and we are given the price of the coffee. Let us say price of coffee is p2. Okay, initially let us say quantity demanded of tea is 10 units, and price initially was $20. Okay, now if price increases to 30, okay, then the quantity demanded should also increase. Let us say it is 20. So in this case we can see, if the price of coffee, so I will write here if the price of coffee has increased, okay, then the quantity demanded of tea has also increased here in this case. Then we say that tea and coffee are substitutes of each other, and it goes other way around. That is, if the price of coffee decreases, then the quantity demanded of tea will also decrease. Okay, so now we will come to the question. Okay, we are given x1 is function of p1 and p2, that is x1 is the function of price of good x1 and price of good x2, and also x2 is the function of p1 and p2. Okay, now two commodities would be substitutes of each other if the cross partial elasticity of demand is positive. By that, what we mean that, let us say I write E1 2, that means uh, cross partial elasticity between quantity, that is quantity demanded of good x1 and price of x2, that is p2. It should be equal to, that is equal to the partial derivative of x1 divided by, that is the partial derivative of x1 with respect to p2 times p2 divided by x1, and it should be greater than 0. And similarly, uh, partial cross partial elasticity of demand between, that is p e21, there here it means that cross partial elasticity of demand between good x2 and price of x1, it should be like this, that the partial derivative of x2 with respect to p1 times p1 divided by x1. So I will write it capital here. It should be also greater than 0. Now what does this mean? That simply means if this coefficient comes out to be positive and this coefficient also comes out to be positive, then we say that the two commodities are substitutes. I hope I am making myself clear, but I will give you an example. What does these terms mean? So I will rub it here. Okay, let me rub this. Let us say we are given the two commodities. The demand function is like this: q1 is equal to 200 minus 5 times p1 plus 4 times p2. Let us say we are given this is the demand for coffee, and let us say q2 is given by, that is 300 plus 2p1 minus 4p2, that is t. We can think of this like this, that x1 is the function of p1 and p2. Here q1 is the function of p1 and p2. Similarly, x2 is the function of p1 and p2. Here I have taken q1 as the function of p1 and p2. Okay, these are the demand functions of coffee and tea. Okay, now what does this mean, what we have discussed till now? That means if we take the partial derivative of, let us say, of the first equation, that is, if we take the partial derivative of the first function with respect to price, that is partial derivative uh, dq1 divided by dp2. That means partially differentiating this demand function with respect to price, that is p2, price of the commodity 2, or price of commodity 2. Okay, so here we can see when we take the partial derivatives, we hold other variables constant. In this case, we assume this p1 is constant when we take the partial derivatives. I have made the videos on the rules of differentiation, and you can check it how do we do the partial differentiation. Okay, so if we differentiate this constant, its derivative would be 0. Since p1 is assumed to be constant here, so its derivative will be also equal to 0, and we are left with this. Since we are differentiating with respect to p2, that means the derivative of p2 would be equal to 1. We get 4 into 1, that is equal to 4. Okay, and which obviously is greater than 0. Similarly, that means change in quantity demanded of Q1, that is good Q1, with respect to the change in the uh, price of Q2. Okay, and it comes out to be here positive, which is greater than 0. Similarly, if we take the partial derivative of this function, that is, and I have told you, if t, here in this case, if coffee is the substitute of tea, that means tea is also the substitute of coffee. That is why we are taking the two partial derivatives. That means the derivative of q2, that is change in the quantity demanded of q2, in this case is t, with respect to the change in the price of coffee, which is p1 here. So we differentiate this very function partially with respect to price, p1. So if we take the derivative of a constant which is 0, the derivative of p1 is 1, we get here 2. And since we are taking partial derivatives, we hold p2 constant, so this is 4 into constant, so the derivative of constant is always 0, so which comes here positive. Okay, in this case we can say that coffee and tea are the substitutes of each other. Okay, and we can also calculate the uh, cross partial elasticity of demand, that is cross partial elasticity of demand, that is equal to del q1 divided by del p2 times p2 divided by q1. Okay, if we try to solve, since this comes out to be 4, so it will come out to be positive in any case, given the price. Here the price would be always positive, so we will get a number which is greater than 0 when we solve this very term. Okay, I could have shown it here, but because of the lack of the space, I will not be able to solve it. So let us say I will still try to solve it. Let us say the price of coffee was 20 and price of tea was originally 20. And here, since we got the value of this dq1 divided by dp2, we got the value here 4. So in place of this, I can write 4 times the price of p2 is 20 divided by q1 is this very function. And if we put this function here, we are given this is 200 minus 5 times p1, that is 5 times the value of p1 is 20 plus 4 times the value of p2 is 20. Okay, when we solve this, we will get a positive number. Similarly, we can calculate elasticity to one, that is elasticity, cross partial elasticity between uh, here in this case the cross partial elasticity between quantity demanded of T, which is here Q2, that is Q2, with respect to the price of coffee, which is here P1. Okay, and it will also come out to be del Q2 divided by del P1 times P1 divided by Q2, and when we try to solve it, this will also come out to be greater than 0. Okay, so similarly two commodities are said to be complements of each other if these very partial derivatives, these two partial derivatives come out to be negative. Okay, so I will rub this. I hope I am making myself clear. So we can also solve it for the complements. That means two goods are complements of each other if increase in price of, let us say, good X, that is increase in price of good X leads to quantity demanded of good Y to decrease. Okay, in this case let us try to give an example, though the example is not perfect one, but I will still try to give the example. Let us say we have car and petrol. Okay, and let us say we have quantity demanded of car, we denoted by x1, and price of petrol, let us say it is given by P2. Okay, the cross partial elasticity between quantity demanded of car and the price of petrol would be something like this. Let us say we have 10 cars to be demanded when, and the petrol price was, let us say, $20 per barrel, sorry. Let us say the price of the petrol increases. Okay, if the price of petrol increases, then it will, then if it leads to uh, in this case, if it leads to decrease in the demand of decrease in the quantity demanded of car, let us say by 5, then in this case we say car and petrol are substitutes of each other. Okay, and similarly we can form the demand function for these two. Let us say we have q1 is equal to 200 minus 0.5 p1 minus p2 square, and q2 is equal to 1000 minus 8 p1 square minus 100 p2. Okay, in this case what we can see here, if we take the partial derivatives, that is, let us say this is the demand for car and this is the demand for petrol. Okay, then the partial derivatives would be something like this, that is dq1, that is partial derivative of q1 with respect to del p2, that is a change in quantity demanded of car with respect to the change in the price of the petrol. So we differentiate partially this very first function with respect to p2 here, that, and holding p1 constant. So the derivative of 200 would be 0 since it is constant, and we assume p1 is constant, its derivative will be also equal to 0. Here the derivative of p2 square would be, this 2 will become the coefficient and we will get minus twice p2, and here we can see which would be always less than 0. Similarly, if we can take the partial derivative of this very function, that is del q2 divided by del p1 that means uh, change in the quantity demanded of the petrol with respect to the change in the price of car. Here that is change in the quantity demanded of q1 with respect to the change in quantity demand of p1. So we partially differentiate this very function with respect to p1 holding p2 constant, because we are taking the partial derivative. So these two will get 0 because these two are the constants. Here and this 2 will become coefficient and it would be multiplied with this 8. This will become 2 8s are 16. We will get minus 16 p1, and here it is also less than 0. And we can easily say that these two goods are these two goods are complements of each other, because we got the coefficient of cross partial elasticity of demand as 0 in both the cases. Okay, so car and petrol are complements of each other, and in the same way, if car is the complement of petrol, that means that petrol is also the complement of the car. Okay, so coming to the question, so I hope I have made myself clear. Then the question would, in this case, will be like this. That means the correct answer to this question should be that is change in the quantity demanded of good x, that is change in the quantity of x1 with respect to the change in the price of x2 is greater than 0. So I will write here two goods are substitutes of each other. Here in this case, when dx1 divided by dp2 is greater than 0, and simultaneously dx2 divided by dp1 are greater than 0. So the correct option to this question would be this option C. And if the question had asked us about the complements, then this very option should have been correct. That is the coefficient of partial derivatives, rather the coefficients of price elasticity of demand should be less than in this case. That is in complements, and the case would be that del x1 divided by del p2 should be less than 0, and simultaneously del x2 divided by del p1 should be also less than 0. So I hope I make myself clear in this video. Thank you.